Hello everyone, welcome back to the series of data structures and algorithm, and in this episode we will be diving deep into one of the most fundamental topic called complete binary tree. 皆さんこんにちは。データ構造とアルゴリズムシリーズへようこそ。今日は基本的なトピックである完全二次分木について深く学んでいきます。A tree is a hierarchical data structure which consists of nodes connected by edges and is widely used in computer science for organizing data like file systems, network routing, and databases. 木構造はノードがエッジで接続された階層的なデータ構造です。これはファイルシステム、データベース、ネットワークルーティングなどデータを効率的に整理するためにコンピュータサイエンスで広く使用されています。This is what a tree data structure looks like. Each element in the tree is called as node. The topmost node or else the starting point of the tree is called as the root. A node that has child nodes are called as the parent node, and a node that descends from another node is called as the child node. A node with no children are called leaf node, and a node that has at least one child is called internal node. The level of a node means the distance from the root, the starting level at 0. Degree of a node is where the number of direct children it has. The height of a node is the longest path from the node to a leaf. Types of trees in data structures: general tree, binary search tree, AVL tree, and heap tree. In general tree, each node can have any number of children. In binary tree, each node can have maximum of 2 children. Binary search tree is a binary tree where left side of the root is less than the root and the right side is greater than the root. AVL tree is a self-balancing binary search tree. 木には様々な種類があります。一般木、二分木、二分探索木、AVL 木、B 木などがあります。A binary tree is a type of tree where each node has at most 2 children, a left child and a right child. 二分木とは各ノードが最大で2つの項、左の項と右の項を持つ木のことです。A complete binary tree is a special type of binary tree where all levels are fully filled except possibly the last level, which is also filled from left to right. 完全二分木とは最後のレベルを除いてすべてのレベルが完全に埋まるノードができるだけ左に寄せられて二分木です。The key properties of complete binary tree. In a complete binary tree, each level except possibly the last is completely filled. All nodes appear as far left as possible. Each non-leaf node has exactly 2 child nodes. The last level is filled from left to right, efficient for storing in arrays because of predictable indexing. 完全二分木では最後のレベルを除いてすべてのレベルが完全に埋められています。すべてのノードは可能な限り左側に配置されます。各批判ノードはちょうど2つのノードを持っています。最後のレベルは左から右に生まれます。Identifying complete versus incomplete binary trees. If there is a missing node that causes gaps before the last level, it is not a complete binary tree. Also, if the last level does not filled from left side to right side, it is not a complete binary tree. 最後のレベルより前にかけているノードがある場合は、それは完全二分木ではありません。 This Java program checks whether a given binary tree is a complete binary tree using level order traversal with a queue. So let's break it down step by step. At the beginning of the code, we have import linked list and queue to use queue for level order traversals. Next, we have defined a node class representing each node in the binary tree. And in each of these nodes contain data which store the value of the node, and left and right which references to the left and right child of the node. The constructor initializes data and sets both child nodes to null. Next, we have created a binary tree class, and this class represents a binary tree with root as its starting point. And inside this class, we have created a method called isCompleteBinaryTree. The edge case is if the tree is empty, it's considered complete. A queue is used to perform level order traversal, and the variable flag is used to track if a non-full node has been encountered. Here it has started BFS traversal, extracting a node from the queue. This conditional if statement is checking whether if the left child exists. If flag is already true, it means we previously found a non-full node, so return false. The tree is incomplete. Otherwise, add it to the queue for the further traversal. If the left child does not exist, set flag to true, marking that we found a non-full node. If the right child exists, if flag is already true, it means we encountered a missing node before, so return false. Otherwise, add it to the queue. If the right child does not exist, set flag to true. If the loop completes without returning false, the tree is incomplete, so return true. Then we'll move on to the main method, where it builds and checks the tree. At the beginning of the main method, we have created an instance of binary tree, and then we have manually build a complete binary tree, where this tree satisfies the CBT condition. All levels are filled except possibly the last level, which is left aligned. And then we are checking if the tree is complete by calling isCompleteBinaryTree method and printing the result. And the sample output should be the tree is complete binary tree. Since the tree we have given is complete, the function returns true. So let's run and see whether this works. Yes, it prints as the tree is a complete binary tree, because what we've entered here, it makes a complete binary tree. So function returns true, therefore it prints as the tree is a complete binary tree. So let me simply say how does this work. The BFS traversal ensures that we process nodes level by level, and the flag ensures that after finding a non-full node, no further nodes should have children. If we find a node with children after encountering a missing node, the tree is not complete. And when I summarize this code, we used level order traversal with a queue, used a flag name variable to track non-full nodes, checks for completeness efficiently, and returns true if the tree is complete binary tree, otherwise it is false. This Java program implements a complete binary tree using an array. So let's go through it step by step. First, we have created a class named complete binary tree, which simulates a complete binary tree using an array. A tree name, an integer array that stores the binary tree elements, variable size tracks the number of elements currently in the tree. The constructor initializes the array tree with a given capacity, like max number of nodes, and the size have been initialized to 0, which means the tree is empty. Next, the insert method. Here, inserts an element to the tree at the next available index. The tree is full. It prints as the tree is full. Otherwise, it adds the value at tree and then increments the size. Elements are inserted level-wise, left to right, ensuring it remains a complete binary tree. Each new element is inserted in the next available position, preserving the complete binary tree structure. Next, we have created a print method which prints the elements of the array in level order. Inside the main method, we have created a complete binary tree with the capacity of 10. And then we have inserted elements, 7 values to the tree, and then we have given the command to print the stored tree elements in level order. The expected output is the tree elements are stored sequentially in the array from minimum to the highest, like 10, 20, 30, 40, 50 and 60. So we'll run the code and see if the expected output. This is the output that we get. So the code works. The code which we implemented works successfully as it prints the elements of the complete binary tree sequentially. So let me summarize. We implement a complete binary tree using an array. The insertion operation follows level order structure. Print operation displays elements sequentially. We explore about complete binary tree, their properties, how they are sorted in an array, and implemented code to check their completeness and build one using an array. I hope you find this video helpful. 最後までご覧いただきありがとうございます。次のエピソードでお会いましょう。Thank you for watching. See you in next episode. Bye bye.